right, so chapter 1, section 1.2, exponents and scientific notation. So vocabulary, scientific notation, y'all know what scientific notation is, right?
Yeah.
Be able to write big numbers and handle those, and then really, really small numbers, right? We'll talk about that at the end of it. And then you've got properties. Okay, the product property, when you multiply in like bases, you add your exponents, right? Power, anything raised to a power, raised to another power, you multiply those, right?
Yeah.
Power of a product is AB raised to the R is really A to the R times B to the R, right? Negative exponent, negative power rule. Anything raised to negative power changes places, whether it's the numerator goes to denominator, the denominator goes to the numerator. The quotient property, A over B to the R, the power of the quotient property, A over B over R, is really A to the R over B to the R. That power is put on both of them. And then you've got the quotient property here, which is A to the R over A to the S. If you're dividing like bases, then you have to subtract your exponents, right? Identity property, anything raised to the first power is itself. And then zero power, anything raised to zero is no one, right? Grins and giggles. What's 4 over 4? Yeah, we learned that way back in 3rd grade, right? Anything over itself is 1, right?
Yeah.
Yeah, you know why? These are like bases, right? Look at their, this is just nerd out before we go to the next page. Okay? So just chill with me. I'll make that up there. Okay, so like bases subtract, right? 1 minus 1 is what? 4 to the 0, which is what? 1. That's why you get 1. That particular number is raised to 0 power because exponents cancel. So there. So that's the hidden things. All right, so evaluate the following. Depending upon what calculator you have, you may get the right answer, you may not. Please stay with it's the same numbers you got on here. Is the same numbers you got on yours?
Yeah.
Good, okay. All right, so these two expressions are not the same. Do you understand?
Yeah.
There's a difference between parentheses -8 squared and just -8 squared. And you need to know how your calculator handles squaring negative numbers. Okay? I normally put them in parentheses because I try to take order of operations out of the equation anytime I can. Okay, so if you were to look at this, this is -8 squared, right? Which means -8 times -8, which gives you what? 64. Yeah. Now, let's look at the one below. This is -8 squared with no parentheses, right? This would give you, guess what? -64. Anybody know why? The reason is, if you look at the order of operations, this is really -1 times 8 what? Squared. Can be rewritten as that. And that's why. If you think about it, you do your exponents first, then what? So putting that -1 there, have I really changed the overall red equation? No. All right, any questions on this? Y'all good?
Mm-hmm.
See. All right, so you want to give us some try? 15, 20 seconds, see what you can do. See how much math comes back. All right. These are powers of 1s here, right? So really, if you look at the power of a quotient, really says that that's this, is it not? 7 squared, 8 squared, because 2 times 1 is 2, and then 1's power on the 8 as well. So that really is 49 over what?
64.
Can I simplify that?
Yeah.
Yeah, what's it?
7/8.
Oh. No.
Yeah.
You take square roots.
Yeah.
23 over 32. I got calculator? Yeah. Let's type in 49. 49 divided by 64. Boom. Yes. No, it will not simplify. Okay. So here's the big thing. If you deal with fractions, make sure it's in lowest term, right? Simplify. Anytime you deal with fraction, put it in this. So here's your answer. Any questions on that? What about this one? This one should be okay. Should we do this? Give me about 20 seconds. Hopefully the negative copied on yours. We're going to go ahead and do the reciprocal, right? Because that's -2 applied to that whole fraction, which is basically going to do this, right? It turns the -2 into +2. Here's ones, right? So it's 2 squared over 3 squared, which is 4 what? 4 9. Can I simplify that? No. Any questions? Good. Bring you back old memories, nightmares.
Yeah.
Yeah, good. Excellent. That's what we want. All right, so let's see what you do here. I'll give you 15 seconds on this one. All right, so power to power really says this. This is 4 times 2, right? The outside power is multiplied to the inside power. So that's really 2 to the 8th. Anybody know what 2 to the 8th is? How much? Now? 256 out of 16. It's not 2 times 8. That's really 2 times 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 2, right? And that would be 256, right? Okay. Any questions on that? Okay, we're just stepping through these problems. And these are the type of problems that you see on your homework, okay? Because these problems came from your homework. All right, let's deal with some variables. This one ought to be okay. You ought to be able to rock and roll with this one, right? All right. We get away from the numbers and get to variables, you should get a little bit more comfortable, right? Multiply night basis, that's really x to the 4 plus 5, which is what? X to the 9, right? Yeah. Good? All right, so I'm gonna give you about 45 seconds on this one, and then we'll talk about how you approached it and stuff like that. Yep. This is how I approach these. When you have what I call a train wreck, and this is a train wreck, you've got coefficients and crazy variables, right? So the first thing that I do is I start to rewrite it. I pull out all my coefficients. My first one is -4, right? Times 7. All right, so that takes care of those, right? So I can mark those out. Now my next variable is an a. Do I have any more a's?
No.
Okay, good. A cubed. All right, so mark that.
You don't have another B on it. You only have one.
Well, okay. Normally I go in order. And what I mean by order, in order how I get to, or so I'll get to my C's first.
Oh.
Is that okay? So I got a C here and a C there, right? That's 5 plus 1, right? So it takes care of them, and then I'm left with a what? B fit. Now at this point, if I need to rearrange variables, you put them in alphabetical order. We're so ingrained in order, right?
Yeah.
It's crazy. I love chaos. So anyway.
But either way is correct.
Oh Lord, yeah. Why? Why is either way correct? Huh? Go.
No, I got a question.
Hold up. Why? We gonna chase this first. Why would it not matter whether it was A, B, C or A, C, B? No, come on now. If you're gonna speak it, you gotta know why. Come on.
The variable doesn't matter what you use to represent that number.
No. In the good book of math, we learned that when you have the commutative property of multiplication, it doesn't matter. When you have everything tied together by multiplication, commutative property exists, so that things move around. 1 times 2 times 3 is the same as 2 times 1 times 3. Same as 3 times 1 times 2, right? You all get the same value.
Yeah.
Commutative property of multiplication. We learned this way back when, right? That's why. Yeah, I'm big on knowing why. Alright, so this is negative 28. Here's 8 cubed. That's c to the what? 6, and then I got b to the 5th, right? There you go. How do we do? How did my thinking compare to your thinking?
I did use C first.
You didn't see?
I did.
Oh, y'all, woo! I'll have to come over to y'all's house and mess stuff up. Y'all just drive yourself crazy. Y'all got OCD, but it's really CDO. It'll be okay. Alright, so, you see how I approach this?
Yeah.
Okay. I love doing this, letting you work and then check your thoughts against mine, because, okay, I said do math all day. Right? Do you? No. So my thinking is a little bit more efficient. It'll be the same, we'll be correct, but I want you to get you more efficient in your thinking, more successful. Alright, so let's look at this. Alright. I'll let you go. You only get 30 for this. No, really, you only need 20. Alright, so first off, I've got how many? Well, I got x and x, right? And the quotient property says, hey, just go ahead and subtract them, right? It's like bases being divided, subtract. So 5 minus negative, or minus 2, that becomes a plus, right? So that gives me what? X to 7. How many of you moved x to the negative 2 up top to begin with? Anybody? You know what? You're just as right as I am. Because you didn't violate any mathematical principle or law or property. So that's the crazy thing when you start doing exponents, properties of exponents, because there's more than one starting. Right? All right. Any questions on this? Y'all are fly through this, right? Yeah? Yeah? Y'all really do good on this. If you need more time, just let me know, right? Say, hey. All right, so we got a fraction, right? Quotient, raised to a power. So what happens to this 8 and 6 and this 2 and 6? Yeah. The 6 is actually going to both of these, right? So that's really 8x to the 48 over x to the 12, right? Right. So, and then I could just do x to the 48 minus 12, right? Which is x to the 36. Y'all get what I got? Yes.
I did a different way, but I got some.
I know, it's crazy. Which way did you do?
I did what's inside the parentheses first.
Uh-huh.
8 minus 2, and I did 6.
You did x to the 6 raised to the 6.
Yes.
Woo, all
That
right.
was name.
Yeah, you know why? Because what you did was validated by a property of exponents, right? What came first, the chicken or the egg, right? Huh? This right here. Whew, all right. You can get this one. You are solid on it. Okay? So I'm going to give you a minute. Give me a minute on this. All right, when you get something that looks like this, it's crazy. The first thing that I do, it's quotient, right? So I got a top and a bottom. So I do kind of like what I do to clean the house. I take care of everything up top, then I'll go to the bottom, take care of everything down there, then I'll go between. That's my approach. Okay? Because people, the hardest thing on these types of problems is where do you begin? And then you start to second guess yourself, and then you go, oh no. And then you just lost. So we're going to concentrate on everything up on the top. So this negative 3 times 3 becomes what? X to the negative what? Right. That x to the 3 times this negative 3 becomes x to the what? Right? All over x to the what? Alright. I'm not done up top, right? I'm just kind of showing you. So x to the negative 9 times x to the negative 9 will give you x to the what? Negative 18, because I got like bases add their exponent. Over x to the what? Do I have to clean up anything in the denominator? No. I'm good up top. Yeah, I've got a negative power there. I don't care. Let's take care of it by quotient, right? Let's go in between. So this is x to the negative 18 minus 8, which gives me, folks, x to the what? Negative 26, right? Okay. Now, when I've taught this before, and it doesn't matter which level I've taught it at, whether it be 7th, 8th, or on up. This thing right here, where it's x to the negative 18 minus 8 in the green, throws people. Because the quotient throws people because they're like, I got a negative. Where does it go? When you get done with the quotient, everything goes up top. If it's negative, then it will tell you it needs to go to the bottom. Okay? That's a confusion point on the quotient problem. Everything is being worked on one level up top, right? If it comes out to be a negative, move it to the bottom. So that x to the negative 26 really becomes what? 1 over x to the what? There you go. Yeah? All right. Now, ladies and gentlemen, that's our last problem on properties exponent. Right? We spent 17 minutes on the video. Our next topic happens to be scientific notation. Okay? Now, I'm going to teach you how I learned scientific notation. And what I mean by that is, I didn't remember a bunch of set of rules. How many of y'all remember a set of rules on scientific notation? Yeah? Just about every one of you probably in a science class. Don't remember that? All that. I don't. I can't remember that. It didn't stick. I mean, it just doesn't. So I'm going to teach you how I learned. Okay? Can you tell what you're looking at, whether it's a big number or a small number? What I mean by a big number is a number greater than 1. What I mean by a small number, that means it's decimal. Right? Can you identify? Huh? See, if I've got decimals, then it's a negative power. And if I got big number, and I hate to use the descriptive word big number, but come on, folks, greater than 1, right? Then I'm going to have a positive what? That's going to help you know when things are not in scientific notation, how to write it. Okay? You with me? Yeah? All right. So, what am I looking at, folks?
936. Are we talking about?
Are
Are we doing the
Right.
answer?
Yeah, talk math to me. Come on, man. 936 what? 10,000, right? 936,000, right?
10 to the negative 2.
Ooh, all right. Now, hold up. When we write it in scientific notation, we have to have this. A number, decimal, and a number times 10 to some what? Power, right? All right, so this little joker right there, that number in front of that decimal has to be a number between 1 and, guess what? 9. Including 9, right? It cannot be a 2-digit number. And it cannot be, guess what? 0. The absolute minimum is 1. The greatest is 9. Y'all with me?
Yeah.
Good. That should be like clear as mud, right?
Mhm.
Yeah, good. All right. So let's look at this. 0.936, right? I got to get it in scientific notation. So you got to move the decimal, right? I only moved it one time. Why?
That number can't be greater than 10.
Yeah, it's gotta be less than 10, right? The greater than 0.
Yes.
The number in front of the decimal has to be a number between 1 and 9, including 9. So have I done that? 9.36 times 10 to, ladies and gentlemen, negative what?
1.
Negative 1. Now, how do I know it's a negative?
If you give us a decimal place.
It is a decimal number, right? I didn't go, did I move it right? Did I move it left? What did I start out with? A small number, right? When I got done, it's big, right? 0.936. When I got done scientific, it's 9.36, right? 0, small to big, right? Small. Negative number, right? Y'all with me? Yeah. Good. If it's a big old number, when you put it in scientific notation, guess what the end result is? Small number. Right? I know. It's gonna mess with you. I promise you. Let's work another one. Y'all with me? The basic fundamental of scientific notation, y'all solid on?
Yes.
Yes, as far as like the number in front of it, you gotta move it, right?
Yes.
We just kind of working on, is it a positive move or a what? Yeah, I'm gonna brainwash you here. Okay? We're gonna get you thinking like me. That's scary though. It is scary. Alright, so let's look at this one. Let's say, I'm gonna give you 30 seconds. Let's see what you can do. Have a success or a train wreck. Have one of them, right? So, is it in scientific notation to begin with? No. So, let's look at this. 891,000, right? There's that decimal. So I'm gonna move 1, 2, 3, 4, 5. Why am I stopping? 8.91. Why am I stopping in front of the 8? Or, huh? There you go.
It starts with 8.
There you go. So times 10. Now listen. You see these little jumps? How many did I make? 5. If you don't do that simple little thing, you'll miscount. Now, what did I start with? A big number, right? What did I end up with? Thank you. That's positive. Now, here's what I'm talking about as far as knowing. Once you got that wrapped around your brain and you solid, you can look at a number like 8.91 times 10 to the 5th. It's got what type of exponent? Positive. So you know that number's got to be what? Hello? That tells you which way to go with it, does it not? I mean, if you go to the left with that now, you just gonna make it smaller, right? You know what I'm saying? So I'll always work with the negatives and the positives on the exponents, right? Big and small. That's what it tells me. All right. Y'all good? Yeah. Good. All right. So let's go have some fun. All right. So take that one out. Rewrite that. Yeah, I don't know. 30 seconds. All right. So here we go. 7.24. I know that I have to move it 3 times, right? It's a negative, so therefore it's got to get smaller, right? Negative exponents come from small numbers, right? So 1, 2, 3. And then you come back in and fill in those whoop-de-whoops with what?
0.
That's right. 0.00724. Now, I'll tell you something. I always front load my decimal with a 0. Because if not, you got a naked decimal. So put some clothes on, right? Your decimal may not be as pronounced as mine, right? Maybe just a smidgen of a mark or something like that. Now, we're going to multiply them, right? So let me show you what we're looking at. When you're doing this, you're multiplying 3 times 3, right? I think they call it the Manissa, right? The number in front of the times 10 to stuff, it's called the Manissa. pretty sure. Don't hold me to it, but I'm like 99.9% sure. It's not a meniscus. So you multiply your meniscus together, right? If it's not, then tell me what the name of that term is, because there's a mathematical term. So this is really 3 times 3 times 10 to the, when you're multiplying like bases, what do you do to their exponents? You add. Right? With me on that?
Yeah.
Okay. Now, what's 3 times 3?
9.
Is that 9 already in scientific notation? Eight plus -3 gives me what, folks? Thank you. You could put 9 times 10 to the 5th, or you could put 9.0 times 10 to the what? 5th. Both of those are going to be correct, right? When you get done with this, what type of number am I looking at?
Big number.
How do you know it's a big number?
Because
You know what I'm saying? You understand what you're looking at? Life becomes much easier. So I've brainwashed you enough to go think my way on them. Anybody ever heard that approach on scientific? No?
No, I heard it.
Y'all ain't never seen that?
I always thought it was
A list of rules on paper. Now you understand why look, that tells the story, right? Negative exponent, small number, right? Decimal, right? Yeah. All right, y'all good?
Yeah.
Now, okay, can I nerd out with you for a second? Because look, I'm gonna show you. I'm gonna do 2 things right here. What if it was this? 98. What if you came out to be 98.2 times 10 to the 5th? Now, is that in scientific notation?
No.
No. You got to put it in scientific, right? So I want you to think about something. Stop, drop, we'll look at this, okay? I know I got to move it 1 time, right?
Yeah.
Everybody with me on that? So that's going to give me 9.82 times 10 to the, well, I know I moved it once. Now, is it going to be a positive move or a negative?
Negative.
positive numbers greater than 1.
Okay, let's look at something. With me? Because this is really where the benefit comes in. Look what I started out with. I started out with 98.2, right?
Yeah.
What did I end up with?
9.
9. I went from a big to a what?
Small.
So how's my move got to be? Positive. Big number, when you put it in scientific, it gets smaller. It's got to be a positive move, right?
Yeah.
Yes?
Yeah.
Y'all, yeah, that's all hinged on, right? Y'all, yeah?
Yeah.
Yeah.
Y'all understand why I did that problem like that?
Yeah.
If it was smaller and it had scientific, times 10 to something, and then I had to manipulate it, massage it into scientific, if I went from small to big, then it would be a
Negative.
negative, right? Yeah. Okay. Y'all good? Y'all lie. Y'all lie. All right. I'm going to take your word for it. So, last one for the night. You want me to guide you through this, or you want to do it? What you want to do? I'll give you this hint. Here's the hint. Quotient, subtract, exponents from like bases. Fair enough? There's my hint. Give you 30 seconds to rock and roll. All right. So when you have scientific that's being divided, then you need to break it up. You keep the numbers being divided. 4 divided by 2, right? Times 10 to the, what's that, 5?
Yeah.
5 minus 3.
Yeah.
It's the quotient, which means subtraction, right? Yeah. So what's 4 divided by 2? Yeah. That equals 2 or 2.0, doesn't matter, right? Times 10 to the who? Just a second. All right. Nerd out just a little bit more. Yeah, well, before we do that, any questions off this? what if I had this as my answer when I got done dividing? Because you could have that, right? Or you could have that when it came out to being what? Multiplied, right? Yeah, you could. Is that in scientific?
No.
All right. I got to move it how many times? Twice, right? Now, is that a positive move or a negative move?
That's a positive. That's a positive.
All right, let's do this. Raise your hand if you think it's possible. This is Alexis. I heard more people than him. You the only one that's right? Come on, anybody? No? Okay, got some little doubters up here. All right, what about negative? Raise your hand. All right, so the negative is correct, and here's why. Ladies and gentlemen, what did I start out with? And when I put it in scientific, I mean it was, but it wasn't, right? It had the times 10. It kind of looked like it, right? Right? We call that generic. Right? It kind of looked like a generic scientific, right? But when you put it, went from a small number to a what? Big number. So that's two moves that are what? Negative. So I'm going to subtract 2 here, which is going to leave me with what?
6.
Yeah. All right. Now, I don't think it's any more, are there?
No.
Okay. So